In this video, I'm going to show you how you can use Crosser to get your machine data into an Amazon S3 storage service. So in this example that you see on the screen, I have used Modbus as our data source. This could, of course, have been any type of machine connector, other types of PLCs or OPC UA servers, but the concept will be the same. So we use Modbus here as an example. With Modbus, there is no information we can get from the PLC itself on what data that is available. It just presents a flat address space that we need to navigate. So we need to provide that information from this side when we're reading the data. And you can do that either by adding registers that you want to read in the settings on this module. But in this case, especially when you have a large number of registers you want to read, it's usually easier to instead provide that information through a configuration file. And that is what we have done here. And we have uploaded this into our resource library and added that to our flow. So let us quickly take a look at this configuration file. So this is just a JSON file that specifies what data we want to read from this PLC, which addresses to read, how to interpret the data, what data type it is. But with this file, we can also contextualize the data by adding additional information that helps us use this data once it's available in our storage service. So in this case, we've added a name for each of these registers or values that we're reading. We've added a machine ID to specify which machine this data is coming from, and we also added a line ID to say which processing line this machine belongs to and so forth. But here we can add whatever data we feel necessary in order to make this data more useful once it's available in our storage service. So with this information, we can then start reading data. We trigger this module every second to get updates from the PLC. And once we get data from the PLC, we will get something that looks like what you see on the right-hand side. So we get a list of all the registers that we have specified to read, including the additional information that we added in this configuration file. There's also some default values that are added by the module itself. There is an ID which is unique per value, and we also get the unit ID of the PLC itself that was used when reading this data. So this is what we have to work with. And we can take this data as is and send it to Amazon, but just to show you some small tweaks of the data, which is typically something you want to do before you send it onwards. I've added a couple of modules here to make some changes to the data. So first of all, we want to have a timestamp with each of these measurements. So we added a timestamp module, and then we iterate over all the tags in that list and change each of them by copying this timestamp into each of the individual tags. And we also remove these default things that were added by the input module because we were not interested in them. So we get a slightly simplified message, but that contains the information that we're interested in. So at this point, we will have data that we could send to AWS as is. But usually when you upload data into storage services, you don't want to upload too small chunks of data. You want to collect data and upload at least a little bit larger chunks, since they will be stored as a file in the storage system. So to do that, we've added this next module where we first append data to a local CSV file, and then we rotate these files at a fixed time interval, in this case set to 5 minutes. So every 5 minutes we will create a new file, and when we rotate these files, this module will send an output containing the name of that file that was just created, and this is used to trigger the final module, which is the module that will upload that local file into the AWS S3 service. And if the upload was successful, then this final module will also remove the file from local storage, so we don't start consuming a lot of local storage space. So this is a very simple example showing you how you can get machine data sent into an AWS S3 service. This is just a starting point. It can of course be extended. You can add multiple PLCs as inputs. If you have more data that you want to collect, you can do other types of restructuring and processing of the data before you send it up to the AWS service. But this is just to give you an idea of how you can easily transfer data from an on-premise machine source into a cloud service. Thanks for watching.